Okay, in this video we are going to do part 3 of the East Texas series of tutorials learning how to use the map module conceptual model approach in GMS. And the previous two versions of this model were a simple one-layer model with a flat top and bottom elevation. And so now we are going to convert it to a two-layer model. And this diagram at the bottom part shows a north-south cross-section. So if you were to take a slice right through the north-south direction, we are going to create some layer elevations on our grid that models this as a two-layer model where the upper layer corresponds to some upper sediments and the second layer corresponds to some lower sediments which only go part way over. So the grid is going to go all the way over to this bedrock, but the bottom part's going to be cut off a bit. And so we're going to interpolate the ground surface here using a raster DEM, digital elevation model, and then the top of the lower sediments and then these bedrock contacts are going to be interpolated using some scatter points, which we will import and use interpolate using the interpolate to modflow layers command. And then we'll do some things playing around with the wells, how they're assigned to a particular layer. But it's mainly, the main objective of this tutorial is to show how to create more realistic layer elevations, and also to illustrate how your conceptual model input changes when you have multiple layers. We have to designate what layer each of our parts of the our boundary conditions and sources and sinks can be assigned to one or more layers now when we're dealing with a multi-layer model. So I'm going to push this off to the side, and then once again there's a this is associated with the tutorials you can download from the Aquavale website, part 3, and I've already downloaded and unzipped part 3, and there is a start.gpr file here which I will import, and this has our solution basically from part 2. We have the two wells. Let's see, let me see if I can turn off that grid for a second. Turn off these scatter points, turn off the background image, and you can see, here are we have drains, we have our rivers, we have wells, and we have our aquifer properties in each of the different packages. Okay, so our next step is to do file save as. We're going to call this East Texas 3 Texas 3.gpr, and next we have a grid. Right now we have a one-layer grid, and we're going to convert this to a two-layer grid, and the way you do that is you just create a new grid. So we're going to say map to 3D grid, and it says, well, this is going to delete your existing grid. Say OK, and defining a new grid will delete your current mod flow and mod path data. That's OK, we're going to recreate it. So we're back to the create finite difference grid dialog. And again, we're going to make the cell size 20 in X, 20 in Y, and the only difference is now in the Z direction, we're going to create two layers instead of one. So that creates our two layers, our two-layer grid. That's layer 1, this is layer 2. They're colored with, let's see, we've got an elevation data set that it's using at the moment, so that's why they're colored differently. And after we create the grid, the next thing is to do the build polygons command. Excuse me, not build polygons. New simulation, the top command in the wrong layer. So we'll say OK here. And now we are ready. Now that we have the ModFlow data activated, we're going to do activate cells and coverage. And but before it says the following layers are not assigned to any polygons and will be inactivated, layer 2. So we're going to get cancel for a second. So what we need to do is, if you go into the rivers coverage setup, it says default layer range 1 to 1. So by default, our properties are assigned from layer 1 to 1. So we want to turn on this layer range field. And you don't normally mess with that when you have a 1-layer model. With a 2-layer model, this is something that we need to turn on. And so we're going to click OK. And now we're going to go to our, I'm going to turn that grid off for a second. I'm going to go back to this rivers dialog, where this is where we have this in the rivers coverage, excuse me, this is where we have the polygon that defines our active and inactive zone. So I'm going to use the select polygon tool and double click on that. And you'll notice it goes from layer 1 to layer 1. Well, we need it to go from layer 1 to layer 2. So in other words, we want it to define the active zone for both layers 1 and 2. Now the reason we do this is it's possible that you could have one polygon for layer 1, a different polygon for layer 2. You know, if you wanted to use polygons to define your active and inactive zone as it changes with depth. And sometimes for complex models that can be really useful. And so now we have that worked out. I mean, if we were to go in here now and double click on this general head, it's going from layer 1 to 1, but that's okay. We want our river boundary conditions, which are defined using the general head package, we want that to be in layer 1 because the river intersects the model right at the top. So now if we say activate cells and coverage and turn our grid back on, you'll see that both of these layers now are completely active, and their active zone has been defined by the by this same polygon. Okay, now you'll notice when we built our aquifer layer 1 coverage as part of our first exercise, this defines our hydraulic conductivity. And originally we used it for top and bottom elevations, but we turned those off here. But it defines our hydraulic conductivity. Well, in this case, we want one hydraulic conductivity for layer 1 and a different hydraulic conductivity for layer 2. So what we are going to do is we are going to just make a copy of this aquifer layer 1 coverage. And I'm going to double click on that. And we're going to call it aquifer layer 2. Now notice down here it says default layer range 1 to 1. A minute ago we created a coverage where we turned on this layer range property, and what that allowed us to do is for points, lines, and polygons that are sources and sinks, we can designate the layer range on an object by object basis. But for aerial properties, you can't have polygons that overlap, so generally we don't, I mean, there's a layer range option here, but another way to do it is there's a default layer range. And if you set this to be, I'm going to change this to be layer 2 to layer 2, then I don't need to specify the layer range on individual polygons. It just defaults to layer 2. So that's what we're going to do here. And now there should already be a polygon there. Let me turn this off. If I double click on that, it says 5.5. Now this is the hydraulic conductivity we use for the upper zone. Now the tutorial, the one I'm following, it doesn't have you change the K value. I'm not sure why it used to be that way. So I'm just going to change this to 2 so that our lower layer has a different hydraulic conductivity than the other layer. I mean, otherwise you don't really need 2 polygons. You can have one polygon that covers both layers. But since we have two polygons, and they really are different layers, that's the whole point of doing the two-layer model. So I'm gonna make that change, and then we'll save our changes. And so our next step is to define our layer elevations. Now, what we have here, we have a couple different things here. If you look down in the right here in the GIS layers, I just toggled on a raster called elif10.tif, and this is a DEM for the site. It has the ground surface elevations. And how do you get that? Well, you could go to the file menu, select import from web, and then using your map locator, you could go into this window and pick one of these. This worldwide elevation data is usually a good option, and so that allows you to, it will import a subset of that worldwide elevation data that just fits your screen. And so that's what has already been done for us. Whoops, somehow that got zoomed in. Let me zoom in a little more here. And so that's going to define our ground surface elevations. And so I'm going to select interpolate to mod flow layers. And we want this to go to top elevations of layer 1. So I'll click map and then click OK, and that will churn for a minute. It shows you the progress down here. That's a lot of points, so it takes a minute to interpolate. And now if I double click on this mod flow top elevation array, you'll see that we have these continuously interpolated values. Instead of having a flat ground surface, it's now interpolated using this raster. So I'm going to turn that off, and then we are going to interpolate these other two elevations. I'm going to turn on some scatter points. Now we have a set of scatter points, and this has already been imported, and we have a bottom one and a bottom two. So there are two data sets on the scatter point set, and we learned how to import scatter points in one of our earlier tutorials. And when we do that, it gives us a set of points, and then it has a set of values for the bottom elevation of 1 and another set of values for the bottom elevation of layer 2. And these are presumably picked off of borehole logs, geologic maps, whatever data you have. And so what we're going to do now is we're going to say interpolate to mod flow layers again. And because of how these were named, they're automatically connected here in terms of our mapping. I'm going to click OK. And now, so here is our top elevation of layer 1. And this is our top elevation of layer 2. Let me look at this in the array. So this is layer 2, and these are definitely lower. The other one, the top elevation, was like 225 or something. And then if we go to the another way to access that is through this bottom elevation array. So this is the bottom elevation of layer 1 and the bottom elevation of layer 2. And so you can see on layer 2 it's low down here, and then it slants up as you go closer to this bedrock outcropping. Now again, if I were to, let me pull this image again, looking in at our diagram in cross-section mode, so we used a DEM for this top surface, and then for the bottom of 1 and the bottom of 2, we did these other two layers. Now, the bottom elevation for layer 1 goes straight across, and the bottom elevation for 2 goes up. So what happens if we go in and look at this, and I'm going to select a cell. I'm going to go into side view. Let's see, that's front view, side view. Here we go. And let's turn off the grid frame, turn off the map module data, and turn off our scatter points. So now what you can see here is so this is layer 2, and over on the right hand side, so this is south to north cross section, and so on the right we have the north. And you can see we have this inverted layer here, and so we need to fix that. And what we want to do is we want to, over here where it pinches out, we want to inactivate layer 2 over here, and then we want to take the bottom elevations for layer 1 and have them match this surface here. And you can do that using the truncate to bedrock option that we reviewed in our 2D scatter point interpolation tutorial. So we're going to do check simulation, run check, and it says, you know, it correctly flags these errors that we've had. And so we're going to do fix layer errors, and we're going to pick truncate to bedrock, and then we're going to pick layer 2. It has 3,400 errors. That means that's how many cells are inverted. And we'll say fix affected layers, and OK, and run check again. And we get a few warnings. Our hydraulic conductivities aren't fixed. We need to do that in a minute. And so now, let's see, if we go into, now this is layer 2, and this is layer 1. So we're looking at the top elevations of each one. So layer 1 goes all the way across the grid, and now layer 2 is kind of truncated. And if I pick a cell here somewhere and go back into side view, you'll see that what I was talking about before. So this is our bottom layer, gets pinched out right here, and then the top layer gets stretched up as we go. And by the way, we have some Z magnification going on. This is what it looks like at its true scale. So this is kind of a thin layer down here, and then a little thicker layer up top. So, well, that was fun. And now we are ready to do map to mod flow. Let's see, wrong packet. Let me go back to my conceptual model. And feature objects, map to mod flow. Now what this does is it assigns all of our, it puts our drains and our wells and our rivers, everything gets assigned. Now right now, everything's, all of our sources and sinks are attached to layer 1. Let's check our hydraulic conductivities. Let me look at this array here. So we should have 5.5 in layer 1 and then 2.0 in layer 2. So that looks correct. And our recharge is not layer dependent. And so, yeah, we should be good to go. Let's do check simulation now. And it says cell dimensions change more than 50%. So there's a big cell next to a small cell. I'm not going to worry about that. So let's save our solution and run mod flow and see what we get. So there we go. What happens here, we got a cone of depression here around our well, like we had before. And if I select a cell right around that well, and then go into side view, what are we going to see here? Let me go back and increase this Z magnification again. And so we should see that well. That yellow dot is kind of hard to see because it has a yellow background, but our well is entirely within the upper layer. And as I kind of cycle through my columns here, you'll see there's not a big amount. There's a very slight cone of depression when you look at it in side view. If you go back to plan view, you can see a divot in the contours right there. Let me do something here. I'm going to turn off the cell edges and switch to color fill and linear from my contour options. So here we go. Now you can see it more clearly, that little cone of depression there. But the question is, do we really want the well entirely in the top layer? what are our options here? And maybe it is in the top layer. It depends how it's drilled, right? If I go into the wells coverage and I double click on this well, there's nothing about the layers here, but if I look at the coverage setup, the default layer range is 1:1. So if I want to turn on the layer range here, and now if let's look at well number 1 first. We want it to be in layer 1 because that's the only active layer over there. But well number 2, we could make it go from layer 2 to layer 2. Let's see if that works. Let's save that and run mod flow. See what happens here. So now it looks mostly the same. And if we go to layer 2, now we're going to see some nice drawdown in layer 2. And that's where the well is located. Let's verify that. Let me go in here and select. Let me turn the cell edges back on. And I'm going to zoom over here for a second. And I am going to select a cell right by that well and go into side view. And I'll be darned. That looks to me like it's still in layer 1. So let's figure out what went wrong here. Oh, you know what went wrong? I think I forgot to do map to mod flow, right? Let's try that again. Let's go back to our conceptual model and let's say map to mod flow. And now, yeah, you can see it changed right as we did that. So now that well is in layer 2. So let's try that again. Let's run it again. That was my mistake. I skipped a very important part. And now we have, okay, so it does look different now. There's less drawdown in the first layer. And there's drawdown in the second layer. The shape of that cone of depression looks different than it did before, so that's really interesting. So we've got it correctly represented in layer 2 now. Now what if your well screen spans both layers? And what do we do in that case? So let me go in here. I'm going to double click on this point. I'm going to say, what if we go from layer 1 to 2? So it spans both layers. Now, by the way, another way to do this is you can turn on the use screen option and you can give it the elevation of the top and bottom of your screen. And that's probably the best way to do it. And when you do that, it automatically determines if that screen is entirely within layer 2, it puts it in layer 2. If it's entirely in layer 1, it puts it in layer 1. But if it spans both layers, or if you have the layer range spanning multiple layers, what it does is it takes the flow rate that you've entered and it partitions it between the two layers based on the thickness of the layer and the hydraulic conductivity. So it multiplies for each layer the thickness times the hydraulic conductivity to get a transmissivity, and then it does a kind of a weighted partitioning of the flow rate based on the transmissivity of the layer, which is kind of what happens in real life. It's not perfect, and in part 4 of our tutorial, we're going to use a more sophisticated way to represent that well, but let's give this a shot. In other words, in part 4 of our tutorial, we're going to use a more advanced well package that does a more intelligent partitioning of the flow. But let's see how it works. Oh, whoops, I did my same error I did before. I forgot to do map to mod flow. So let's do map to mod flow. Now it puts a well. Now you have a well in both layers, and if we go to the well package dialog, you'll see that it has, well, I take that back, it puts the entire pumping rate in each of those two wells. And so it doesn't partition it. I was thinking of a different of the scenario with I think with the screens it partitions it according to the overlap, but when you just do layer 1 to layer 2, it puts that same pumping rate in both layers. So I guess if we want this to be truly representative of what's going on, I mean, we could come in here and say and change these to where we probably have to do it based on what layer we're looking at. But by doing it this way, we've effectively doubled the pumping rate. So I'm going to go in here and I'm going to use the select cell tool, and I'm going to say sources and sinks, and instead of being minus 300, this is the top layer has the bigger hydraulic conductivity and it's thicker, so I'm going to say minus 250, and then I'm going to go to the lower layer, and I'm going to right click on that and say minus 50, so it's going to partition that flow out. And you could partition that any way you want, but that's just an example. So now let's do save. Oops. Yeah, that should work. Save and run. And if we do map to mod flow again, that'll get wiped out. But now here's our cone of depression in layer 2. And here it is in layer 1. Again, they look pretty similar. Let's see. So yeah, that's basically, let's go back and look at our flow budget to make sure that worked out correctly. We should have a total pumping rate of minus 350, so that worked. Anyway, so that's how you deal with multiple layer models. To recap again, we split our grid into 2 layers. We interpolated top elevation from a DEM, bottom elevations from scatter points, used the fixed layer errors option in the check simulation dialog to truncate this part of layer number 2. And then we played around with how those wells are partitioned between the layers. And I made a couple mistakes along the way, but I think we're able to catch those. And by the way, that's why you should always look at your solution and see if it's reasonable, because sometimes you just miss something. And so this has been a good exercise, and we'll come back with our next video and do part 4.